So in this question, you're asked to design a go-kart racetrack. So the first thing I'm going to do is I'm going to draw a picture. So here's my racetrack. This is the top view, so a bird's eye view looking down. So I'll just say this is from above. I've got my car right here. And so this direction I'm going to call R. So towards the center of the circle I'm going to call R. And my Z direction is out of the page. So I'm not going to draw it here. And instead I'm going to draw the back of the car. So here are my tires. This is the kind of the body of the car. And so this is, I'm looking at, imagine this is the trunk of the car. And so my Z direction, this would be positive Z, and then this is my R direction. This is going to be positive R. So my free body diagram is going to look like I've got the normal, force of the normal, and I have the force of gravity, and then I have the force of static friction. So there's my free body diagram, and I've already, I'm just going along at my rubric. I've done my picture, and I've done my coordinate system, and I've done my free body diagram, so now I'm going to go with the sum of the forces. And so here I'm going to do the easiest one first, and I'm going to look at the sum of the forces in the Z direction. So the sum of the forces in the Z direction are equal to 0, and that's because my car is not going off of the ground or going into the ground. So my sum of the forces are, the positive is in the or Fn is in the positive Z direction. So I have Fn minus Fg equals 0. So now I know that I have the force of static friction here, so I know I'm going to need the force of the normal for that equation. So I'm just going to solve. So Fn, the force of the normal, is equal to Fg, which is equal to mg. So I've got my sum of the forces in the y direction, or the z direction, and now I'm going to do the sum of the forces in the r direction. So that's the sum of the forces in the r direction is equal to ma. And now the ma for circular motion is going to equal mv squared over r. Okay, so now what are the forces in the r direction? And if I look back at my free body diagram, I can see there's only one, and that is the force of static friction. So now I know the force of static friction is equal to mv squared over r. My force of static friction I know is mu s times mg is equal to mv squared over r. So I know my masses cancel here. The masses are the same, so I can cancel those out. And the question is asking me, what is the radius required? So I want to get the radius alone here. So the way I'm going to do that is I'm going to multiply both sides by r, and that'll put my radius up here. So I'm going to have r mu sg is equal to v squared. And so to get r alone, I'm going to divide both sides by mu sg. So I'm going to have v squared over mu sg. Okay, so I've done my forces in the or my r direction here, and now what I'm really doing now is I'm solving for the unknowns. Okay, so what about this velocity? What am I going to put in there for velocity? And if I look back up here in the equation, it says that typical go-karts reach speeds of 24 kilometers per hour. So the first thing I'm going to do is I'm going to convert that velocity to meters per second. So velocity equals 24 kilometers per hour, and let's move that. Let's do that over here. So velocity is equal to 24 kilometers per hour, and so I need to multiply by 1,000 meters in 1 kilometer, and then I need to multiply by 1 hour is the same as 3,600 seconds. And so when I solve for that, I end up with 6.67, I think it is. Oops. So 6.7 meters per second. And now if I look back up at the problem, it says that the maximum speed of the go-kart, so this is the maximum speed of the go-kart, this 6.7 meters per second, is 4 times slower than that allowed by the coefficient of static friction. So that means that my go-kart track has to be designed for a speed 4 times faster than this speed. So my velocity here to calculate my radius has to be 4 times this. 4 times 6.7 meters per second, and that's equal to 26.7 meters per second. So that's the value I'm going to plug in here. So now I've got R equals, and now I can plug in. I've done all of my algebra that I needed to do, and I know all these values. So my V squared is going to be 26.7 meters per second, and that's all going to be squared. Divided by mu s is 0.2 times g, which is 9.8 meters per second squared. And so when I multiply that out, I end up with r is equal to 364 meters. So I have meters squared over second squared, and I have meters over second squared. So I can see my second squareds cancels out, but I'm still left with 1 meter. And so that's my answer for the radius. So I'm done with part B, and now, or part A, and now I'm going to go on to part B. And this is asking, now instead of using the coefficient of static friction, if I want to use a banking angle, how would I go about doing that? So I'm going to draw my picture again. So this is my above view. I still have my racetrack and my car. And Z is coming out of the page at me, and my R is this way. This is R. And so again, I can't really see what's going on. So I know that my racetrack is going to be banked. So I'm going to draw the picture like this. And so my car, let's see if I can draw this. This is going to be tough. So this is those are my tires, and this is my car. And so this is the back of my car. This here would be like the trunk. And so my coordinate system is going to be, this is my Z, and this is my R. Now why is my coordinate system like that?